You ever look at a set of numbers and just see, well, a jumble? The average, the mean, it tells you one thing, but the real story, the juicy details, that's almost always hiding just beneath the surface. So today, we're going to learn how to dig in and find that hidden narrative, because that's how you turn plain old data into something that actually means something. Okay, so here's our jumble of numbers. Looks pretty random, right? What you're looking at are the gallons of fuel wasted every year by commuters in 15 big US cities. And just staring at it like this, it's pretty much impossible to see any kind of pattern or story. So that's the big question, isn't it? How do we take this raw, messy information and turn it into something that actually makes sense? Something that tells us a story about traffic and waste, and maybe even which cities are doing things a little bit better or worse than the others. Here's our game plan. First, we're going to slice our data up using something called quartiles. Then we'll zero in on the middle of the data and find a way to spot any real oddballs. After that, we'll build a powerful picture of the whole thing, and finally, we'll learn a really cool trick for comparing totally different kinds of data. All right, first up, quartiles. And honestly, the best way to think about this is like slicing a pizza. Instead of one giant, intimidating pie, you get 4 equal, manageable slices. We're going to do that exact same thing, but with our numbers. So, what are they? Quartiles are just 3 points that chop our data set into 4 equal chunks. You've got Q1, which is the 25% mark. Then there's Q2, which is the 50% mark, and that's just a fancy name for the median, the number smack dab in the middle. And finally, Q3 is the 75% mark. Simple as that. But first, you can't slice a messy pizza, right? Same goes for data. Step 1. Always is to arrange our numbers from the smallest to the largest. And watch what happens when we do that. That middle number, our median, just pops right out. For our 15 cities, that middle value is 25. That's our Q2. So finding the other two is super easy. To get Q1, we just find the median of the lower half of the data. See that? It's 23. To get Q3, we do the exact same thing for the upper half of the data, which gives us 30. And just like that, a story is starting to take shape. We now know that a quarter of these cities waste 23 gallons or less, and 3/4 of them waste 30 gallons or less. Okay, now that we've divided the data, we can do some really cool things. We can focus on that middle chunk, kind of like the heartland of our data, and we can set up a clear rule to find any values that are way out on the fringes, the rebels, if you will. The tool we use for this is called the interquartile range, or just IQR. It's nothing more than the distance between Q3 and Q1. It tells us the spread of the middle 50% of our data. And the best part? Because it totally ignores the lowest 25% and the highest 25%, it doesn't get skewed by some super high or super low number. It's a really stable way to measure spread. So for our fuel data, the IQR is just 30 minus 23, which is 7 gallons. What does that mean? It means that for the typical middle-of-the-road cities in this group, the amount of wasted fuel only varies by about 7 gallons a year. That's a really nice, clean summary of what's normal for this data set. We've defined what's typical, but what about the extremes? How do we decide if a value is just a little bit different, or if it's a true outlier, something really weird? This is super important because an outlier could be a mistake, sure, or it could be your most important discovery. And you know what? There's a simple, standard rule for this. It's a little bit of math, but it's easy. We take our IQR, which was 7, and we multiply it by 1.5. Then, we subtract that result from Q1 to get a lower fence, and we add it to Q3 to get an upper fence. Anything that falls outside these fences, well, that's a potential outlier. Okay, let's do it. Our IQR of 7 times 1.5 is 10.5. Our Q1 was 23, so 23 minus 10.5 gives us a lower boundary of 12.5. Now let's look back at our ordered data. And there it is, the number 11. Since 11 is less than 12.5, we've officially found an outlier. There's one city in our list that is wasting way less fuel than the others. That's a finding that was totally invisible before, and now it's a mystery we'd want to solve. So, we've found our quartiles, the IQR, and even an outlier. Now, how do we pull all of this together into one single picture that tells the entire story in just a glance? We do it with something called the 5-number summary. And it's exactly what it sounds like. It's the 5 most important numbers that give us a snapshot of our data's position and spread. We've got our minimum value, our 3 quartiles, and our maximum value. These are the vital stats. And we can visualize this whole summary using what's called a box and whisker plot. It is an incredibly powerful way to see the center, the spread, and the overall shape of your data all in one neat little package. And reading it is a piece of cake. The box in the middle, that shows you right where the middle 50% of your data lives. That's our IQR, from 23 to 30. The line inside the box is the median, right at 25. And the whiskers? They stretch out to the minimum and maximum values. See how that left whisker going down to 11 is way longer? That's a huge visual clue telling you, hey, look over here, we have an outlier. All right, for our final piece of the puzzle, we're going to zoom in from the whole dataset to look at single data points. We're going to learn a technique that lets you compare completely different things in a fair, standardized way. I'm talking about comparing apples to oranges, or say the height of a man to the height of a woman. The magic key here is the z-score. Instead of just looking at a raw number, a z-score tells you how many standard deviations away from the average that number is. It's like it creates this universal yardstick that you can apply to any set of data, which is what makes it so incredibly useful. And here's a super handy rule of thumb. If a z-score is somewhere between -2 and +2, we think of that value as being pretty normal, pretty typical. If it's outside that range, it's starting to get unusual. And if it's beyond -3 or +3, it's considered very unusual. Let me show you how powerful this is. Take a 6-foot-tall man. His z-score is only 0.7. Yeah, he's taller than average, but it's a pretty usual height. Now take a 6-foot-tall woman. Her z-score is 3.0. Her height is 3 full standard deviations above the average for women. That is statistically very unusual. Same height, 6 feet, but totally different stories. The z-score gives you the context that the raw number just can't. So there we have it. We went from a messy pile of numbers to a clear story. We found the middle, we understood the spread, and we even sniffed out an outlier. We even learned how to compare individual things in a really meaningful way. So that just leaves one question. Now that you have these tools, what hidden stories are just waiting for you in the data you see every single day?